Awesome. Thanks, Ben. Hi, everybody. My name is Devin Swiner. Like Ben said, I go to The Ohio State University. Tonight, we're going to talk about my most recently published work that's titled A Proof of Concept Two-Tiered Approach for Ricin Detection Using Ambient Mass Spectrometry. But before we get into that, just a little about me. I was born and raised in Upper Marlboro, Maryland, so I'm a Maryland girl, East Coast. I went to the University of Pittsburgh and graduated in 2016. I got my bachelor's of chemistry. I got my bachelor's of science in chemistry, and then I have minors in sociology and Africana studies. While I was at Pitt, I worked under Dr. Tara Meyer, and my job there was to kind of study the mechanical properties of synthetic polymers that her lab was synthesizing. And that was kind of my first taste to analytical chemistry, and that's what I'm doing now. I'm an analytical chemist. I'm graduating in May, so that's exciting. And I work under Dr. Abraham Badu-Tawiah, and my goal and my job in the lab is to develop mass spec methods for clinical diagnostics. And what is a good introduction without a few fun facts? I am one of the Black and Chem co-founders. So I don't know if some of you were following Black and Chem, but I was one of the brains behind that movement. I also like to think of myself as MC Hammer's Twitter best friend. We follow each other on Twitter. I can tweet him and he'll tweet me back. So, social media rules go, that makes us best friends. I'm a STEM advocate. So I have been a part of Nobuche for, as long as I can remember. In undergrad, I'm currently serving as the chapter president for Ohio State's chapter. And there is our picture for a couple people on my right. I've been working with Nobuche so long that Sierra and I won an award in 2018 for mentorship and leadership. And then I also have a blog called Mac Sciences, and this is our handle for all social media platforms. And that got me an award in 2018 from the Women's Chemist Committee for encouraging women into the chemical sciences. And the last thing, as you can see, I wear many hats. I'm a science communicator. So if you want to keep up with that, you can also follow me on my professional website, devinthechemist.com. So on to the research for tonight. So the project I decided to talk about was my ricin project. And I thought that this was perfect for, a broader audience because it's something that people may have heard of before. So I just kind of clipped some news articles where ricin has been the topic of conversation. So you might have heard, politicians or presidents getting sent white powder in an envelope. A lot of times that's ricin. A little less commonly known ways to be exposed to ricin is for suicide attempts or overdoses. So I kind of clipped a couple of articles here. So because of that, there's an issue. We have to try to find really good ways and really effective ways to detect ricin in a wide array of matrices. So how can you get exposed to ricin? So like I said, the first scenario we're going to talk about for a little bit is the scenario where you have an unknown white powder that you get mailed in an envelope. You can also be exposed to ricin from inhalation, injection, ingestion, and also in castor oil. So ricin is found in the castor bean seed, and that is where we get our castor oil from. So there are very low levels of ricin in various castor oil products. So like paint coatings, laxatives, soaps, waxes, but they're not enough to, be lethal. So don't fret, it's okay. But it's just, these are the places where we can see ricin kind of rear its ugly head. So just to kind of orient everyone, so how much ricin it takes to be lethal, here's a case study. So let's say we have two patients, patient X and patient Y, and let's say they both weigh 80 kilograms. Patient X injected or inhaled, a ricin extract, whereas patient Y ingested it. For patient X, it would only take about a 0.5 milligram to be lethal, but for patient Y, it takes about 1 gram or 5 castor bean seeds, if you will, to be lethal. Now, the thing with ricin poisoning is that it is based off of, how much the patient weighs. So there is, a little flexibility. People that weigh a little more, it would take more ricin. People that weigh less, it would take less. But this is just, it doesn't take much, essentially, to be lethal for ricin. So I'm not going to go through this figure, but it just kind of goes through a step-by-step of how ricin behaves when it gets in the cell. So the biggest thing to know is that ricin is a large protein that has 2 different chains. So an A chain, so that's this chain in blue, a B chain, that's this chain in purple. The B chain is what what is used to penetrate the cell, and the A chain is for ribosome inactivation. Now, ricin is only toxic if you have both the A and B chain, and if both chains are still active. So this means that the detection methods that we use for ricin have to be able to tell us both things. Is the A chain and the B chain there, and also if they're active or not. So because of this, this is just a non-exhaustive list of some of the techniques that people currently use for ricin, but if it's inactive. I mean, as you can see, a lot of them like are ELISA-based. There's some mass spec methods in various matrices with various, sensitivities, but they do take a long time. So as little as 15 minutes, but also some can take about a day. But this isn't that interesting to us because, like I said, you want to know if ricin is going to be toxic or not, and telling us if it's inactive doesn't really give us much information about it. Conversely, there are other techniques that can detect ricin if it is active. But as you can see with the ones that I've highlighted here, they take about a day to 2 days. Some of them are mass spec based, so I listed a couple here. A lot of them map the adenine release. So that's what they use as a marker for ricin. And a lot of them are also cytotoxicity assays. So as you can see, all of these take a lot of time. And I like science that doesn't make me wait 2 days. So that was kind of the goal of this project. So what we did, or what I did rather, I took a step back and thought about where ricin came from. So like I said, this is the plant that it comes from. So it's the castor bean plant, and these are the seeds. In the seeds, you have all of these things. These are just the 3 that I wanted to highlight. So you have ricinoleic acid, which naturally exists as a lipid, and that makes up the bulk of castor oil. You also have ricin, and then you have this small molecule biomarker called ricinin. And what's special about ricinin is that it naturally exists in a 5-to-1 ratio with ricin. So what we did was look at ricin indirectly. So instead of looking at the large protein, I looked at 2 small molecules. And I used ricinoleic acid for a screening test. And then I confirmed the presence of ricin using ricinin. And this only works because all 3 of these analytes co-extract from the castor bean seeds if you were to try to take a ricin extract. So it's kind of a quick way, indirect way to look at ricin without actually having to handle the protein, without worrying about being able to detect both chains and also their activity. So we're not the first people to think about looking at ricinin for confirmatory tests for ricin. A lot of these papers, this isn't exhaustive, but a lot of people have been doing this. This puppy paper was really sad. So a puppy ate like a bunch of beans and it was fatal. So that was really sad for me to read. But a lot of these other papers kind of looked at extracts from castor beans or looked at patient samples. So the goal of this work was to develop a platform that could look at both ricinin and ricinoleic acid from both of those early scenarios that we talked about. So the scenario where ricin is mailed to someone and the scenario where someone, has an overdose or attempts suicide using ricin. So how did I do this? This work, like I said, is recently published. So this is the citation down here. So feel free to take a picture of that if you want to read this work in depth. But conventionally, you would have to do a lot of sample preparation with a potential ricin sample. And then you'd have to look at the bioactivity. And that takes, hours to a couple of days to do. So in the conventional case, we have an indirect sample because you are treating your sample or doing some kind of manipulation to it, but you're detecting ricin directly. What I did was I would screen my samples for ricinoleic acid and would look for a yes/no response. So if I was able to see the peak that I want and its subsequent fragments, then I would go on and look for ricinin. If I didn't, if it was a no, then we could conclude that there wasn't ricin present in this sample. Now, if we found ricinoleic acid and was looking for ricinin, we do the same thing. I would look for and fragment the ricinin peak. If I saw the fragments, then that's a confirmatory yes, we have ricin present. If we don't have ricin, then it's a non-poisonous sample. The good thing about this is that it only takes me 2 minutes to do. So I don't have to do any form of sample preparation. So it's a direct sample, but it's an indirect detection because I'm taking advantage of small molecule analysis. Now, because this only takes 2 minutes, I'm not saying that, when you get this first no for ricinoleic acid that you can't go look at ricin, because you can. Like I said, 2 minutes. It's really quick. So if you still want to do the check, both like the two-tiered approach for both of these small molecules, you can still do that and you're not losing any time. So why is this important? This is important, and my work falls under the umbrella term called ambient ionization. And ambient methods are really great because you really save on time, resources, cost, and you get a quicker turnaround for diagnostic type studies like this one is. So a lot of us might be, familiar with the conventional LC, GCMS workflow. So you would do sample preparation. Your separation takes, an hour to 2 hours per sample, kind of depending on what you're looking at, how many things you're looking at. And then the mass spec is the easy part. You're really just seeing if you see your peaks and your subsequent fragments. With ambient ionization, it only takes 1 to 2 minutes to do total. So you don't have to worry about sample preparation. You could take and analyze these raw samples, and it's really sensitive still. So this figure is just to kind of show you how broad ambient ionization is. So in the middle of this figure, you have different types of samples, patient samples that you could take. So you have neonates, regular people, and then you have elderly, community. These are not exhaustive of the types of biological fluid samples that you could take. So urine, tissue samples, gastric fluids, blood, saliva, things like that. And these are a lot of the ways that you can analyze those types of samples, whether you're doing traditional electrospray, so that would be like a needle approach. If you have low polarity analytes, you would use some form of plasma or laser to do that. You can use solvent, so that'd be like a desorption electrospray kind of technique. But what I'm going to talk to you guys about tonight is using paper and thread to do ambient ionization. And this falls under the term of, the subclass of ambient ionization called substrate-based methods. So in these methods, you deposit your sample onto a substrate, and you can extract, ionize, and transfer your ions to the mass spec in a single step. So for some ambient methods, the extraction and ionization step are separate, but for the substrate-based methods, they're all happening at the same time. So how did I do this? So to mimic scenarios 1 and 2, to mimic a mailing envelope, I took paper strips and I deposited a 4 microliter ricin in solution on them. Let the paper sample dry for a little while before housing it inside of a glass capillary. I just used melting point capillaries, so things that I'm sure a lot of us are familiar with. Housed the paper strip in here, applied solvent, appropriate voltage, and was able to form gas phase ions that get transferred into the mass spec. So thread spray is the method that I've been developing in my lab, and the citation down here is for the first paper on thread spray. I will also answer any questions that you all have about thread spray. But I take spool thread, and when I say spool thread, I mean I went to the fabric store, bought a spool of cotton thread. The same thread spool that I bought when I started graduate school was the same one I'm still using now. So I cut that. I did a gas phase surface treatment on the thread to make it hydrophobic. So that's why I have this like yellow box outline around the thread. Dipped it into the biofluid sample. There's no drying time with thread spray, and did the same thing. So I housed the thread inside a glass capillary, added appropriate solvent and voltage to generate these ions that get transferred into the mass spec. So first things first, like I said, it's a two-tiered approach. So tier 1 is a screening test, and this is for a paper sample. So this is the chemical structure of ricinoleic acid. And for anyone that does mass spec, they would look at this and say, okay, Devin, this isn't that interesting for mass spec. And what that means is this molecule is relatively hydrophobic. And with mass spec, you want to make sure you can confirm, the presence of these ions. So just because this would ionize at 297 doesn't mean that if I was to add energy to it and break it apart, that those fragments would be specific to this compound, because it's really hydrophobic. It doesn't have that many interesting functional groups. So the only peaks that we were looking for, that I was looking for, was this water loss peak and this CO2 peak. Anything that's got an alcohol or carboxylic acid, carbonyl, could also lose these things, which is why I used it for a screening test. I wanted to just see, like, okay, there might be ricin here because it appears that this 297 peak could relate to this ricinoleic acid. So in this case, I would call this a positive test. This would be a yes for me. It's important to note that this 183 is from an isobaric compound in the mass spec, that something ionizes at the same mass to charge ratio, and this peak is unrelated to the ricinoleic acid analyte. So we have a screening check mark, yes, and then I'd go look for ricin. Ricin is a confirmatory ion for ricin because it gives me specific fragmentation to ricin. So in this case, I'm looking for a 138 peak. So that's this peak right here. So I fragmented this 165, which is, intact ricin with the charge on it, and looked for its main fragment peak. And that's what we see here. Similar case for paper. Paper and thread aren't clean surfaces. So there are lots of things, whether they're additives, dyes, things like that, on the surface of these substrates. So you will see some interference in a lot of these tandem spectrum. But in this case, I see the peaks that I want to see. So that's 2 yeses, which means we would conclude that there was ricin in this sample. I can do the same thing for biological fluids. In this case, I looked at urine and serum because those are the most common that people test for ricin poisoning in right now. So we did the same thing. So I would look for ricinoleic acid. So we see the 2 peaks that we're supposed to see. And then you also can do the second step and do ricin detection in urine and serum. And this is way easier, a lot cleaner. The hydrophobic thread warrants higher sensitivity than traditional paper does, which is great. And I'll be happy to answer more specific questions about that later if you all have them. But in this case, we can do it with regular paper samples and also biological fluid samples. A method is really only as good as its quantification capabilities. So that's what I did next. I quantified how much ricin I could actually detect. Since this is the confirmatory ion, this is the ion I want to make sure I can detect in very low concentrations. And as you can see, these LOD and LOQs are low PPT ranges, which is great for us, which means the hydrophobic thread spray method is sensitive enough to detect ricin, like low levels of ricin in different patient sample types. And that's important because that means someone doesn't have to, overdose completely before being able to say, okay, they were exposed to ricin or things like that. I could look at trace levels of ricin in someone's urine or in someone's serum and be able to confirm the presence of ricin by using its small molecule biomarker. The last thing I did was I put them in a mixture just to make sure that I could do these things from the same sample. So this is just, a representative spectrum for urine analysis with hydrophobic thread spray. And as you can see, this works really well. It doesn't take that long to do. The other thing to note for this method is that these 2 ions are in 2 different polarity modes, which is really nice. So this ricinoleic acid is in negative mode, and then this ricin is in positive mode. So not only can I switch between modes to do this analysis, it still only takes me 2 minutes, and it still does this high level complexity screening for a poison. So in conclusion, hopefully I was able to convince you all that you can use cellulose materials, something simple like paper and even simpler like thread, to detect these small molecule biomarkers in different matrices. I don't have to worry about offline separations. There's no pre-treatment steps. It's really just to deposit the sample and go. I can also modify the thread spray platform to look at paper strips. Traditional paper spray methods use paper triangles, but I don't have to worry about that in this case. The hydrophobic thread is the best substrate for biofluid detection, which is really awesome that, we can get PPT level detection for ricin, which is really on par for non-lethal dosages. And then the added benefit of using multiple biomarkers is that you reduce the likelihood of false positives. And that's really important for work like this that could be scaled up to help, in real life situations, because I can look at 2 biomarkers in 2 minutes with it still being, this sensitive. It has an immediate, field capabilities, which is really awesome for, the work that I've been doing. So I'd like to give a special thanks to my advisor. This is him right here, Dr. Abraham Badu-Tawia. Also want to shout out to Sierra. Sierra and I, during grad school, have been helping to validate the thread spray platform. We've been splitting the most common mass spec applications between the 2 of us. So Thank you to Sierra. I also want to thank my undergrads, George and Hannah, for working on this with me, and my other group members, which are all, kind of pictured here. And then Ohio State for funding this, also ASMS for funding this, and then Ben for inviting me to talk a little bit about my research, and you all for watching this live stream. So with that, I would like to say thank you all for your attention. Here's all my contact information. If you want to talk more in depth about any of my work or any of the million things that I'm doing, here's my email. You can always connect with me on the website. And then here is Twitter. I'm pretty much on Twitter all the time. So feel free to drop me a DM, shoot me a tweet, things like that. So yeah, I'll be happy to take any questions.
All right, as promised, that was a really interesting talk and a really cool
Thank
technique.
you.
And you do have lots of questions.
Oh,
So
awesome.
yeah, we'll go ahead and get started. So Kyle asked, is there a correlation between ricin activity and ricin in terms of ricin interacting with the protein?
As far as I know, no, they're not. A lot of people, a lot of people attack the ricin issue by looking at small molecule biomarkers. So, from my understanding, there isn't any levels of interactions between the two. So it's just kind of a cheap way to do it, really, without having to like worry about all the extras that you would have to worry about for ricin. So.
Okay. So this is one I had. So when you're
Yeah.
talking about housing the thread, how do you house the thread without affecting the sample? And how would, like, if this was commercialized,
Mhm.
how would that sample, or how would the substrate look? I mean, I know it may vary depending on who makes it, but in general, how would those substrates be prepared?
So the beautiful thing about thread is that it's absorbent. So I don't see any interference with, threading the capillary. I really just push the thread through the capillary when I do
Okay.
this work. So because the beauty of using a cellulose-based material is because honestly, it's absorbent, so we don't have to worry about the sample going anywhere.
Okay.
Sometimes I get questions about, transmission of the biological fluids, and that's all I work with into the mass spec. That's
Mm-hmm.
also limited.
Okay.
So the idea is to play on the properties of the substrate and kind of use that to our advantage. Commercialization wise, we're working on the best way to do it. The limiting step for it, though, is the threading the capillaries. So
Okay.
we're thinking about something similar to like a holder that would hold, multiple capillaries,
Mm-hmm.
in series with each other, and
Okay.
then threading the capillary that way. So that's what we're thinking. But we're trying to find a good way to like draw that and explain it to someone that can
Sure.
make it
Yeah. Yeah. That's
conceivable for
that's
everybody
always
to
the
use.
tricky part.
Yeah.
Okay, I mean that's smart. It's interesting that you're kind of already thinking ahead to that.
Yeah.
Okay, so let's see. So what happens if the thread is not treated to make it hydrophobic?
So I can still use hydrophilic thread. So every time I give a talk about hydrophobic thread, I don't want to say that, oh, it is the most sensitive. But I do use the regular hydrophilic thread for other work that I'm doing.
Hmm.
It's just for this work, because ricin is a little hard to ionize, I had to kind of play around with solvent. And the hydrophobic thread has an added benefit of things not fully absorbing into the inner core of the thread, so which would make
Okay.
it harder to extract things back out of. So how I like to think about it is that the hydrophobic layer kind of rests, kind of uses is a barrier
Hmm.
essentially, for the analyte and the thread itself. So your analytes will kind of rest on top of the thread while your matrix kind of absorbs into the thread, because the inner workings
Okay.
of the thread is hydrophilic. I work with biological fluids, which are hydrophilic in nature. So
Okay.
those would, diffuse into the thread. Your analytes would stay on top. So, your solvent has more access to your analytes, which increases sensitivity. So that's really the best added benefit of using the hydrophobic thread. The
Okay.
hydrophilic thread is still useful. And it's still useful because it's inside of a glass capillary. So because of that, the solvent still has really good access to, your matrix, your analytes of interest,
Hmm.
because it's all surrounded by solvent. So the hydrophilic thread is still really good for things. I kind of go through different surface modifications
Hmm.
in my first paper, and talk about, like what they're useful for, which ones are better, why they're better. So there's like a really good discussion in my original, hydrophilic
Okay.
thread spray paper. But the hydrophilic thread is still sensitive. It's just the hydrophobic thread is more sensitive than that one
I
is.
got you. Okay, so I guess basically the hydrophobic lets you use maybe like a smaller sample size or something like that.
Basically,
Okay,
yes.
all right. Let's see. Okay. Oh, yeah. This is one. So I'm familiar with mass spec. I've not really done a lot with it, but I sort of had the general idea. But one thing I don't
Mhm.
know that you had talked about was um, how. So you talked about knowing what the primary fragment was that you were looking for, and that like so you could look for those certain peaks. Is that something that comes from experience, or is that something where you can predict it and basically say, okay, looking at this molecule, this is probably what's going to come off first, or
Mhm.
how this is my I'm a chemical engineer, a pretty poor chemist, so like
No, you're fine. You're fine. So a lot of the things that I look at, other people have looked at. So a lot of stuff you can kind of just look up. For like in literature, saying like, oh, here's the most common fragment that a lot of papers have published to look at. So we look for those first. But if I was to kind of have like a random molecule, I would look for the most labile bond. So whatever in this case, whatever is the easiest bonds to break,
hmm
that forms the most stable fragment, is how we like
okay,
to think about it, is what will be lost first.
that
And,
makes
it, and
sense.
knowing, the energy that you need to collide these molecules with to generate the fragments that you want without, the molecule rearranging and doing weird stuff like that.
hmm
That's just a part of the optimization. But the overall goal for doing, what this is called tandem mass spectrometry, which is, looking at the fragments of your analytes, is looking for what forms the most stable neutral loss. So
Okay,
in this case, HCN is a really stable neutral loss. This would be really easy to break. So this was the minus HCN peak was the peak that I would use.
okay,
Similarly for this one, if you put a proton here, water would fall right off.
hmm
Or right here, water falls right off. Carboxylic acids are infamous for losing CO or CO2. So
hmm
those mechanisms are known as well.
okay,
But yeah, so you want to look for the most stable neutral loss first when you're
hmm
doing tandem mass spectrometry.
okay. And I guess you could also pair it like if you wanted to be really sure, you could like what you're talking about with the commercial one where you had multiple capillary tubes all together. You could have one that was like just the blank substrate and
Yep,
compare and have that as like a control, basically, right?
exactly.
Okay. All right. So our next question here is from chemist Craig. He wants to know: is the sample size consistent when you use the thread?
Yes. So I use 10 microliters of samples always for thread spray. The paper strips, I use 4 and I optimized for 4, but this was the only project that I used the paper strips. And this was just to kind of mimic the other scenario, more common scenario for ricin exposure.
hmm
But anything thread spray is always and forever will be 10 microliters. So any
Okay.
optimization experiments, any calibration curves, everything is 10 microliters.
Okay. Uh, Kothapalan actually had a question about your standard curve. So how often do you need to create your standard curve?
I calibrate it once for whichever analyte I need quantification for. So thread spray in general is very reproducible.
hmm
So like these air bars are really good
Yeah, I
and
was about
kind
to
of
say those
show
those are
that
very small.
um, yeah, it's really reproducible, which is great for me because one calibration tends to do the trick.
Yeah.
So yeah, I just calibrate it once just to kind of get a gauge on how sensitive the detection actually is.
Okay.
So then I would use the same curve because it's so consistent. I would just use the same curve if I want to do like a quality control sample. So
Okay.
just the one time.
All right. That's really handy then because that helps a lot in putting it to actual work.
100%. Yeah.
Okay, so let's see. Our next one's from Kyle as well. He wants to know how much do the fatty acid and ricin vary between samples from castor oil or from castor oils?
So I didn't extract ricinoleic acid from castor oil.
Okay.
But because it is like the main component, it makes up like 60% of castor oil.
hmm
Um, they're Ricinoleic acid and ricinin are from two different parts of the seed. So if you were to do an extraction from the seed itself, you'd have an oily part and then you'd have like a watery part. So
Okay.
your ricinoleic acid comes from the oily part and your ricin comes from the more aqueous part. So they don't really interact with each other as like a whole lot, because the ricinoleic acid exists as a lipid naturally in the seed.
Okay.
If that answers your question, Kyle.
I think so. Let's see. Okay, we have a good one. This one I think is from Isaiah. He says, as an organizer for Black and Chem, that had to take a lot of courage and confidence. When in your walk as a Black chemist did you find that voice?
Oh, that's a great question, Isaiah.
Yeah.
I actually don't know. I feel like I've kind of always had this voice as I, transitioned from undergrad to grad school. But once I passed candidacy, it was like a light switch, honestly. Because I think for a lot of PhD students, it's like, okay, after candidacy, you feel like you have some weight, behind, your science and behind your
Hmm.
words. So I was like, oh, okay, cool, I got this. So then it just kind of went from there, I suppose. But I'm kind of always like this. So,
Hey, nothing wrong with that.
I'm really consistent. But yeah, that's a really good question, Isaiah.
That's good. Let's see. Okay, so we have one from Ice Tritium who's asking: are there cases where ricin is present without ricinin and the ricinolenic acid? And
Mm.
they're asking basically about a case where something like pure ricin is used.
That's a good question. So they would be hard to separate. So they do co-extract, and there's a lot of literature that, tracks the pathways that ricin take, like when you do an extraction. So they would be really hard to have one without other, which is why I wanted to focus and do quantification and confirm, these studies with ricin because
Hmm.
it is a well studied pathway. So I don't know if there's a case where you would have ricin and not have ricin. Now, ricinoleic acid is a little different. You probably wouldn't have as much ricinoleic acid if it was like a pure extract of ricin
Hmm.
because it's from a different part of the seed.
Okay. Okay. Yeah. Okay. That's interesting. I wouldn't have realized that, but that's good to know. Isaiah has another quick question. He wants to know, how does it feel to be a celebrity?
How did I know you were going to ask me that, Isaiah? I don't classify myself as a celebrity. I'm just a graduate student that is giving a talk right now on a Friday night. It's been fun meeting people on Twitter though. So that is what I will say to that one.
That's good. So I will. I've got one. This is kind of more of a general question about
Yeah.
this technique. Is it expandable to other? I mean, I'm assuming it's expandable to other applications, but how
Mhm.
readily could, let's say, I don't know, drug testing or even testing for like other biological markers, right? Like, maybe there's something
Yeah.
that signals a certain type of cancer or something like that.
Mhm.
Could this be, with the right work, could it be expanded out pretty easily, or you think, or
Yes, actually. So this ricin project was my second project. My first project was drug screening. So I looked at illicit pharmaceutical drugs in blood.
okay,
So that was all my first paper. What I'm currently working on right now is a lot more clinical. I'm using fatty acids, so saturated and unsaturated fatty acids as obesity biomarkers for
oh,
serum samples. So
okay,
I'm working on that right now, actually. And then we have a collaboration with Nationwide Children's Hospital, and it's more of a metabolomics study,
hmm,
looking for small molecule markers for cystic fibrosis. So yeah,
okay,
Sierra has worked
yeah,
on yeah, Sierra's worked on more like food safety and forensics applications. So she's done like capsaicin studies with the thread. She just published, more protein type paper. So for hemoglobin detection for that. So yeah, you can pretty
yeah.
much do. When I said that we split the applications between the two of us, we did. We split the applications
Okay,
between the two of us and have been doing a lot of cool things with thread spray.
that is really cool. Yeah. Okay. Oh, we got another question here. Also from Ice Tritium. You
Yeah.
wanted to follow up on the recent questions, and any thoughts about
Mhm.
other toxins like the Shiga? I'm not familiar with that one, but maybe you are. I guess basically, could this be expanded out to other toxins as well, pretty
Oh, that's
readily,
a really
or
good
would it
one.
depend on them?
I think it could be, like with the right work. I've done a lot of optimization for thread spray as like a general platform. So looking
Hmm.
at like surface modifications, different modes. So this is more of like an electrospray based process. For this work in particular, my fatty acid project is more of a plasma based
Hmm.
ionization source. So I think so. A lot of times with thread spray, it's really just, a change of solvent typically, and maybe,
Okay.
a quick surface modification because all my modifications are gas phase, which makes them sit it and forget it.
Hmm.
So yeah, I think so. Like with the right work and the right motivation. We weren't too interested in going the toxin route. This was kind of I was playing with ricin for a little while, and then this kind of came out of that. So I'm a little more interested in more biomarker discovery, thus
Hmm.
obesity and cystic fibrosis. But yeah, I think so. I think it does have really cool capabilities for being used for other toxins.
Okay. So I guess I'll kind of piggyback off of that in a slightly different direction. What are the limitations of the technique? Like where do you think it might fall short?
So one of its biggest limitations right now is the fact that it's not commercial.
Okay.
So it's a little hard. It's easy to do because I've been doing it forever,
Hmm.
and it's really easy to teach, but it not being commercialized is a little bit harder to do.
Okay.
Other things, some stuff is just kind of hard to get out of the thread. So overly hydrophilic compounds, if you were to use, regular hydrophilic thread,
Hmm.
would be really hard to ionize. So I was having a little bit of trouble with ricin for a while because it just was not trying to protonate for me at all. So it
Okay.
took me a little longer to optimize for this. But yeah, so it just really depends on the types or the class of analytes that you're looking for. But
Hmm.
overly hydrophilic things that would be kind of sticky, and would like stick to
Mm,
the thread, those would be really hard to look at with this as of right now.
okay. And that makes sense too, but I'm sure you could probably come up with a way to deal with that as well. It
Ideally.
seems like, yeah, it seems like you're able to adapt this really, really well.
Yeah, that's the good thing about it. Sierra and I also looked at different types of thread. So I use cotton thread exclusively, but
Okay.
she's used blends. We were studying nylon for a little bit, polyester as well. So
Mm,
the beauty of it being so simple is that you can really use any kind of thread that you need to kind of
yeah,
fit your application, which is really cool.
that is very cool. This is a really fascinating technique. Like I said,
Thank
I
you.
saw I saw what you had, the sort of short blurbs that you had posted about it, and I was like, this is really cool. All right, so I'll give just a few more seconds here. If anybody has any last minute questions, go ahead and get them in. I think that might be everything.
Awesome.
Yeah, but like I said, that's a ton of questions. I think that's probably the most that have been asked. So that I think that speaks highly of your talk and how interesting.
That's
Oh,
good.
actually, I
Oh,
take that
one
back.
more.
We got one more.
No, that's fine.
Let's see. So Craig wants to know, in general, how easy is it to sort of take into the field? Like, is there the way he's got it phrased is there a mass spec in a suitcase?
Yes. So the whole goal of the work that my lab does, we want it to be portable, and we have a portable mass spec.
Oh.
So there are mass specs that you can physically take with you that are like, bench top, but like really small,
Mm-hmm.
that you can take. So yes, probably the next thread spray grad student in my lab will actually be working more exclusively on, the portable instrument and making sure that, the interface as well.
Yeah.
But yeah, the whole point is that it is really simple and amenable. And because, I can use raw samples and I don't need a lot of sample at all,
Mm-hmm.
is really helpful for it being field ready.
That's really cool. I think you blew some minds in the chat. I see people saying they didn't even know that portable mass spec existed. So
Yes, portables are really cute.
that's awesome.
Yeah.
Well, that's very cool. All right. I think if there's any other questions, get them in. But otherwise, I will go ahead and say thank you to Devin. Again, I knew it was going to be a good talk, and it was. It
Thank you.
absolutely lived up to the billing. I think chat enjoyed it as well. Like I said, based on the number of questions you got, that you generated a bunch of interest. And yeah, so I'd like to say thank you for coming out and And
Thank you
thank
for
you to,
inviting me.
yeah, absolutely. And thank you to everybody for coming to watch. This was a lot of fun, and we'll be back next week. I don't know who's presenting yet, but I've got a couple people I'm talking to, so hopefully somebody will be here. But yeah, thank you to everybody that showed out tonight. I'll throw the Discord link in the chat one more time. Like I said, anybody is welcome to join, regardless of where you're at. And this talk will be uploaded to YouTube, so if you missed any of it, it'll be on there. And yeah, I think that's it for the night. So I will say thank you to Devin one more time, and thank you to everybody for coming.
Yeah,
And
thanks, guys.
everybody have a great weekend.
Alrighty.